Welcome back to the Deep Dive. We're the show that takes the absolute flood of new tech advancements, cuts through the noise, and gets right down to the technical details that matter. If you're like us, it feels like there's a groundbreaking new AI model announced practically every other week. It's a lot to keep track of. So this Deep Dive, it's your shortcut, your way to really get a handle on what's happening at the absolute cutting edge. Today, our mission is to unpack two of the biggest names right now, OpenAI's GPT-5 and xAI's Grok 4. We're going to focus purely on the tech specs, the performance data, their actual capabilities, and what it all means for you. Whether you're a developer trying to figure out which tool to use, a researcher tracking the field, or, just intensely curious about where AI is heading. And as always here on the Deep Dive, we'll zero in on those technical intricacies, the real-world implications of the technology itself. We'll be sidestepping the broader ethical debates or inclusivity discussions for this specific session. Our aim is simple: arm you with the solid, specific information you need to navigate this incredibly complex, fast-moving AI landscape.
Definitely.
And to help us navigate, we've gathered insights from quite a range of sources. We've looked at Founderoo for that crucial historical context from the origin story of OpenAI and xAI. Then we pivot to artificial analysis for some detailed technical comparisons, trying to get those objective metrics side by side. And importantly, to get a feel for how these models perform in the wild, we've sifted through community discussions and performance observations on Reddit, specifically places like R Singularity and RLLM Devs. You often find some really invaluable ground-level user takes there. And of course, we're pulling directly from the official announcements what xAI said about Grok 4 and what OpenAI released about GPT-5. So putting it all together, we get a pretty comprehensive picture, even if sometimes the different sources offer slightly contrasting views on these really powerful new models.
That sounds like the perfect blend: official word, hard analysis, and that crucial real-world feedback. It gives us that rounded perspective. So let's start at the beginning, laying the groundwork. The origins of OpenAI, way back in 2015. It's quite a story, isn't it? Shared vision, but leading to very different paths.
It really is. And it starts with this deep alignment, initially at least, between Elon Musk and Sam Altman. Their early talks, apparently spanning a year, maybe even two, before the official launch in the late 2015, were all about developing AGI, artificial general intelligence.
I bet.
But critically, within a very specific nonprofit structure, the core philosophy back then was to keep AI in good hands.
Keep it safe.
Exactly. They were driven by what they called optimal incentives, meaning, focusing on benefiting humanity, not just chasing profits. That nonprofit ideal was absolutely central to their initial collaboration. And how they met was, pretty standard Silicon Valley. Introduced by a Y Combinator partner, Sam Altman mentioned getting an awesome tour of SpaceX. That kind of mutual respect, that shared experience, it really set the stage.
And what really fueled this vision, especially for Musk, who even back then was, let's say, quite vocal about AI risks.
That's key. Musk's worries about AI going out of control, posing an existential threat, they go way back before 2015. And he wasn't alone, right? You had figures like Stephen Hawking, Bill Gates, sharing that sort of cautious view.
A more conservative approach.
Definitely. But it wasn't just philosophy driving OpenAI's creation. It was intensely competitive, too. Strategic. Think about it. By 2014, Google had already bought DeepMind.
Right, supposedly grabbing like 75% of the top AI talent.
That was the report, yeah. A huge chunk. And Apple was buying up AI startups for Siri, Facebook at Fair. Even Toyota was setting up TRI for AI and autonomous driving. So you had this incredibly rapid advancement happening everywhere, concentrated in these big tech companies. And that fueled the fear, Musk's fear particularly, that powerful AI could end up in the wrong hands.
So OpenAI was the counter move.
Exactly. The idea was, let's create a nonprofit, advance AI safely, make sure it benefits everyone, and importantly, keep it open source, the tech, the patents. A complete contrast to the closed, proprietary approach of the giants.
Okay, this is where it gets really fascinating. Musk's direct involvement in those early days. He wasn't just a co-founder on paper, he was, crucial for getting the right people in the door.
Oh, absolutely instrumental.
Yeah.
He's publicly claimed putting in $50 million early on. And the name OpenAI, that was apparently his idea, really emphasizing that original open, transparent mission.
But the talent part.
That might have been even bigger. Sam Altman himself called Musk a talent magnet. The prime example is Ilya Sutskever.
The brain behind TensorFlow at Google, right?
Exactly, a huge figure in deep learning. Apparently, Sutskever was hesitant to leave Google, the resources, the prestige. But Musk's personal pitch, his vision for AGI safety, his His conviction, that's what reportedly swayed Ilya to join OpenAI.
Wow, so his personal brand was that powerful.
It really shows how critical Musk was in just assembling the raw brain power OpenAI needed to even have a shot at competing back then.
So, given he was so central, why leave? Why the departure in 2018, just a few years in? What caused that rift?
Yeah, it's multi-layered, and it really highlights this growing divergence in strategy and, frankly, philosophy. First, Musk started expressing serious doubts about OpenAI's chances against giants like Google DeepMind.
The ant against an elephant analogy.
That's the one. He apparently felt it was a hopeless endeavor without a massive funding, the kind of nonprofit just couldn't easily raise.
Mhm.
This wasn't just talk, it was a real concern about viability. Second, there was this offer he reportedly made to essentially take charge, bring OpenAI under his wing, maybe integrate it more with Tesla. That offer was rejected by the other founders.
Okay.
The official reason given for his exit was a conflict of interest because of Tesla's own AI work, especially in self-driving. Makes sense on the surface.
But the sources hint at something deeper.
Yes. The Founderoo source strongly suggests a really fundamental factor was OpenAI's pivot towards becoming for-profit. They started this charter funding thing in April 2018.
Just before he left.
Exactly. And only a year before, they officially became a capped profit company in 2019. This move towards commercialization, needing huge capital to compete, it was a massive shift from that original nonprofit open source ideal. Musk later publicly questioned it, right? How could a nonprofit become this multi-billion-dollar for-profit? He said it wasn't open enough. It seems that fundamental change in direction, prioritizing capital over the original open mission, was likely the core reason for the split.
Okay, so this historical tension, this divergence in philosophy, it clearly didn't just disappear. It seems to lead directly to the competitive landscape we see now, especially with Musk launching XAI.
Absolutely, it's a direct line. Musk leaves OpenAI over this philosophical and strategic split, and then boom, July 12, 2023, he forms XAI. And look at XAI's mission. Understand the fundamental principles of the universe through artificial intelligence and create safer artificial intelligence alternatives. It echoes those original safety concerns, that desire for aligned AGI.
But with a twist, maybe?
Potentially. Because unlike early OpenAI, XAI is integrating Grok with Twitter. That implies a significant commercial angle, a path to profitability. So maybe Musk's own views on the nonprofit necessity evolve too.
Interesting. And how does Altman's stance contrast now?
Altman seems to fully embrace AI's power for progress, but he also really pushes for governance, for regulation. He supported the move to profitability at OpenAI, but crucially, he famously owns no equity himself.
Right, which is unusual.
Very. It suggests his focus is perhaps more on the tech's evolution, the competition, rather than personal wealth. And OpenAI LLP still has that safety wing, focused on human-AI value alignment. But the rivalry is still there. You see the little jibes traded online. Musk's very public support for Ilya Sutskever during that whole OpenAI board drama last year felt like an indirect shot at Altman. It definitely underscores the ongoing competitive, maybe even personal dynamic driving this race.
A fascinating backstory that really sets the stage. Okay, let's shift from the origins and dive into the specifics of OpenAI's latest big release, GPT-5. What are the hard facts on its release and availability, particularly for businesses?
Right, GPT-5 officially launched in August 2025. It's out now, currently available for users on the ChatGPT team plan.
The initial rollout.
Exactly. And then for wider enterprise use, it's set to roll out to ChatGPT Enterprise and also the education plan starting August 14th, 2025. And a really key point for businesses. They're highlighting its deep compatibility, its readiness to integrate smoothly with existing enterprise tools. We're talking things like Google Workspace, Microsoft SharePoint.
Which is huge for adoption, right? Less friction.
Definitely. Being able to plug it into workflows people already use securely, that's a major selling point for enterprise clients.
Okay, so the claim is smartest, fastest, most useful. Big words, let's get under the hood. What are the core architectural leaps or new capabilities that justify these claims? What's really new, technically?
OpenAI is framing GPT-5 as being built for deeper, context-aware reasoning. The idea is it can think deeply when you need it to. Now, they haven't released specific parameter counts or training set sizes. That's pretty standard secrecy for these frontier models.
Right.
But the emphasis is clearly on a step up in cognitive ability. Handling really complex, multi-step problems that need sustained thought. They're advertising expertise across tough domains. Math, science, finance, law, you name it. Imagine it tackling, say, intricate legal case analysis, synthesizing precedents from thousands of pages, or modeling complex financial market interactions. That's the kind of depth they're aiming for.
And the hallucination issue. That's always been a major hurdle.
A huge focus here. They're claiming enhanced truthfulness and reliability, and they gave a specific number. Hallucination rate dropping from 13% down to just 1.6% on benchmarks like Health Bench Hard.
13 down to 1.6. That's dramatic.
It's a game changer, potentially. A drop like that makes you start trusting these models in much higher stakes situations. Think legal advice, medical diagnosis support. It could unlock automation for tasks that were just too risky before because the reliability wasn't there. They explicitly say it's less prone to hallucinations and pretending to know things.
Okay, that's reliability. What about for developers? You mentioned coding and agentic abilities. That sounds like where the real action is for our listeners.
Absolutely. This is where it gets really interesting for people building things with AI. GPT-5 is touted as having improved end-to-end coding skills, producing more usable code, better designs across different languages and frameworks, plus augmented debugging capabilities. That's a practical win for any dev team.
Debugging help is always welcome.
Always. But maybe even more exciting is its ability to generate full front-end UIs from minimal input. Like describe a web page in a sentence or two and it builds it.
Yeah.
And crucially, executing long chains of tool calls autonomously. This is the bedrock of truly agentic AI. The model isn't just responding, it's planning, making decisions, interacting with other software, calling APIs, completing multi-step tasks without needing constant hand-holding.
So it can act like a mini project manager or automation engine.
That's the direction. It could manage workflows, orchestrate data pipelines, act as a much more proactive, self-directed assistant for complex jobs. That's a fundamental leap.
A huge leap towards real autonomy. Okay, beyond the core intelligence and that impressive hallucination drop, what about the practical features? What new tools or API options can developers actually use with GPT-5 right now?
There are several interesting ones. First, this novel ability called minimal reasoning. It allows the model to, well, shorten its reasoning chains in the output.
So less showing its work.
Kind of, it's an optimization. You can ask for concise, faster answers when you don't need the step-by-step, or request more detail when you do want that transparency.
But how does it know when to minimize? Is that a setting, or is the AI judging the situation? The sources don't spell that out, do they?
That's exactly the kind of technical detail that's missing. Is it a user-controlled parameter in the API call? Or is there some learned adaptive meta-reasoning happening? Knowing that mechanism would be key for developers trying to really fine-tune its behavior. Then there's a more straightforward verbosity parameter in the API. Lets you dynamically control how long or dense the responses are. Pretty useful for tailoring output to different needs.
Okay, more control there.
For end users, they've added personality and interface choice. Customize the chatbot's personality and even the chat window color.
Personality choice. Technically, how does that work under the hood? Is it just clever prompting or something deeper in the model?
Another great question without a clear answer in the sources. Is it prompt engineering magic? Or maybe manipulating latent spaces within the model? Or are they fine-tuning variants? Maintaining coherence across different personalities efficiently is non-trivial. There's also an advanced voice mode, better speech understanding, and interestingly, user-specific speaking style adaptation.
So it can learn to sound more like me.
Potentially. It hints at sophisticated voice cloning or adaptation, making the interaction feel much more natural and personal. Huge for conversational AI. And study mode. This provides step-by-step, personalized instructional help, not just answers, but adaptive learning paths. Think a tutor that tailors explanations to your level.
Like a personalized learning assistant.
Exactly. Imagine it guiding a student through a complex problem, explaining concepts, maybe even simulating scenarios, all adapted to their pace. And finally, that deep app integration we touched on, securely connecting to and using data from Gmail, Calendar, Drive, SharePoint. That's massive for enterprise workflows, letting the AI work with your existing data ecosystem. It becomes an embedded intelligence, not just a separate tool.
Okay, so OpenAI hasn't dropped a big, comprehensive benchmark paper yet. How do we gauge these performance claims, especially compared to GPT-4 or other models? What's the buzz from the communities actually using it?
Right, so qualitatively, OpenAI is pushing dramatic gains in accuracy and hallucination reduction over GPT-4 and 4 Turbo. And they emphasize that notably higher proactive health reasoning and law science domain expertise, positioning it as a real co-pilot in those complex fields.
But what about numbers, even unofficial ones?
This is where the Reddit community, particularly Singularity, comes in. One user, citing what they claim is internal OpenAI info and artificial analysis data, made some pretty bold quantitative statements. They claim GPT-5 performance is higher than O303 Pro level. These seem to be internal OpenAI model codenames often discussed there. And speed-wise, 2-3x faster than O3 and 10-20x faster than O3 Pro, apparently with similar or better quality.
10 to 20 times faster. That's significant.
Huge, if true. They also claim it's topping 80% of the benchmarks, calling it the new soda state-of-the-art on a tough list, including AIM 2025 Math, GPQA, Humanities Last Exam, HLE, SWE Bench for Coding, MMMU Multimodal, and others. They even gave specific speed numbers, GPT-5 hitting around 190 tokens per second compared to their O3 at 152 TKs, but with the 15's latency. And O3 Pro way down at 20 TKs.
And they confirmed the hallucination number.
Yeah, they specifically cited that drop from 13% to 1.6% on HealthBench Hard. So the reliability claim seems echoed there. Now, the general sentiment on Reddit, it's a bit mixed. Some expressed disappointment, feeling it was maybe overhyped beforehand.
Expectations were sky high.
Exactly. But there's also a lot of praise for its instruction following, how well it does what you ask it to do. One user called it a surgeon for its precision, especially compared to Grok 4, which we'll get to. And this ties into those ideas of emergent reasoning, the model sort of knowing how much thinking is needed for a task. And its agentic pipeline readiness, that ability to autonomously run tool chains, opens the door for things like autonomous software engineering or business process automation. It's moving from tool to orchestrator.
That idea of situational awareness in reasoning and the robust agentic execution, that's incredibly powerful. What are the underlying technical leaps enabling that? Is it a smarter planning module inside? Or just really, really good fine-tuning on complex tasks? This is exactly the kind of tech detail we love to dig into.
It is, and it's right at the edge of what's publicly known.
Yeah.
That phrase OpenAI uses, thinking built in, is tantalizingly vague, isn't it? It could point to a more advanced internal planning component, maybe a dedicated module for breaking down tasks and reasoning step by step, a bit like our own executive function. Or it could be a highly refined form of chain of thought reasoning that was just baked in much more deeply during training and fine-tuning, making these complex skills emerge from the sheer scale and quality of that training data focused on multi-step problems.
So a dedicated module versus an emergent property of scale and training.
We don't know for sure. Is it modular with distinct thinking parts, or a more powerful monolithic model that just learned these skills incredibly well? The ability to run long chains of tool calls autonomously suggests pretty sophisticated error handling, self-correction, maybe even state management across those calls.
Yeah, if one tool fails, does it know to try another?
Exactly. That requires more than just good fine-tuning. It hints at a deeper understanding of the task and how to navigate failures. These are the specific architectural or algorithmic innovations that OpenAI is keeping proprietary, but they're crucial to understanding the real technical jump here.
Okay, fascinating possibilities there. Let's pivot now to the other heavyweight contender, xAI's Grok 4. Launched slightly ahead of GPT-5, right? What are the release details, the availability, and how is xAI positioning this model?
That's right. Grok 4 actually landed on July 9, 2025, so it beat GPT-5 to public release by about a month. It arrived with two flavors, the standard Grok 4 and a more powerful version called Grok 4 Heavy.
2 tiers from the start.
Yep. Grok 4 is accessible to people subscribing to Super Grok or Premium Plus on the X platform. Plus, importantly for developers, it's available via the xAI API. For Grok 4 Heavy, they introduced a specific Super Grok Heavy subscription tier, clearly marking it as a premium high-performance offering.
And it's on OpenRouter, too.
Also live on OpenRouter, yes.
Yeah.
Which gives developers another way to access it alongside other models through a unified interface. Pricing-wise, Grok 4 is listed at $30 a month. Grok 4 Heavy jumps up significantly to $300 a month on xAI's platform. So Heavy is definitely positioned at the higher end for those needing maximum capability.
Okay, $300 a month is steep. Grok 4 made some really bold claims, too, aiming to be the most intelligent model in the world. Huge statement. How did they apparently get there? What are the key technical advancements in training or architecture that xAI is pointing to?
They're building directly on their previous models. Grok 3 focused on that core next totem prediction, while Grok 3 reasoning was about encouraging longer, more complex thought processes. For Grok 4, the big story is scale and reinforcement learning. They threw massive compute power at it using Colossus, that huge 200,000 GPU cluster.
200,000 GPUs. Just staggering.
It really is. They used this cluster to scale up reinforcement learning, basically, training the model through trial and error with feedback and rewards to refine its reasoning and problem solving at an unprecedented pre-training scale. That's incredibly compute intensive. And here's a really significant claim. Innovations throughout the stack leading to a 6x increase in compute efficiency.
6 times more efficient. That's huge at this scale. But how? The source doesn't say how, does it?
It mentions the claim, but doesn't elaborate on the how, which is frustratingly common. A 6x gain is massive. It could point to breakthroughs in the neural network architecture itself, maybe a more advanced mixture of experts, mess up, or perhaps hardware-level optimizations within Colossus, like custom compilers. These are the kinds of fundamental advances everyone's chasing, but xAI is keeping the specifics close to their chest.
The secret sauce again.
Exactly. They also mention a massive data collection effort, specifically expanding the verifiable training data beyond just math and coding into many more domains, broadening its knowledge base while aiming for quality and reducing bias.
Now, one of Grok's big selling points, especially pushed by Musk, is its native tool use and real-time abilities. How is it trained for that? And what's this unique integration with X?
This is a core part of Grok 4's design. It was trained using advanced reinforcement learning specifically to integrate and use external tools seamlessly. It's not just generating text, it's actively deciding when to call a tool.
So it knows when it needs help.
Precisely. Key examples are using a code interpreter for calculations or programming and robust web browsing for fetching real-time info. When it needs up-to-date knowledge, it autonomously chooses its own search queries, digs through the web, and synthesizes what it finds. That independent search strategy is a big step towards agent-like behavior.
And the X integration.
That's its unique superpower. It can perform advanced keyword and semantic searches directly on the X platform. And, get this, it can even view media from X, interpret images and videos posted there to enhance its answers.
So it can tap into that real-time global conversation, including visuals.
Exactly. Access to that massive, constantly updating stream of text and media gives it a real edge for questions about current events, trends, public opinion, or analyzing things people are sharing visually on X. It's like having a direct line to the pulse of the internet curated by X. They even provided a neat example. Grok 4 is solving the NYT connections puzzle. It didn't just guess, it reasoned. It saw the user asking for a crazy word puzzle about legs, formulated smart searches like viral word puzzle about legs and the specific puzzle number. But then it pulled info from X posts and articles, pieced together the clues, and correctly identified that tricky category, homophones for parts of the leg.
Ah, like crypto for toe, Disney for knee.
Exactly. Decaf for calf, Russian for shin. It demonstrated reasoning, targeted tool use, search, and synthesizing information from multiple sources to get the answer. A really concrete example of its process in action.
That's a great showcase. Okay, so Grok 4 Heavy. It uses parallel test time compute. What does that actually mean, and how does it translate to performance on those super hard frontier benchmarks?
Right. Parallel test time compute is the fancy term. Think of it less like one single brain working harder and more like maybe a team of experts tackling the problem simultaneously.
Like running multiple simulations or thought experiments at once.
That's a good analogy. It allows the model to consider multiple hypotheses at once, explore different reasoning paths in parallel, and maybe cross-check its own conclusions before giving an answer. This architectural approach is claimed to boost both performance and reliability, making it more robust.
And the benchmark results reflect this.
They're certainly impressive. Grok 4 Heavy was the first model to hit 50% on the text-only part of humanities' last exam, scoring 50.7%. That benchmark is designed to be incredibly difficult, maybe the last of its kind for closed-ended academic questions. On ARC AGI v2, a benchmark tracking progress towards AGI, it scored 15.9%. That's nearly double Claude Opus's score, a big jump, called the highest yet.
And the vending bench simulation
Dominated it. This is an agentic benchmark, a business sim. Grok 4 Heavy achieved a net worth of nearly $4,700 and sold over 4,500 units. Claude Opus 4 was around $2,100 and 1,400 units. Humans averaged about $840 and 340 units.
So it blew past both other AIs and humans in that strategic simulation.
By a huge margin, it shows really strong capabilities in planning, resource management, decision-making in a dynamic setting. Plus, it hit all-time highs on other key benchmarks. GPK Diamond, 87.5%, AME 2025 Math, 94%, Live Code Bench Coding, 79.4%, USAML Math, 61.9%. Together, these results really highlight its strengths in complex reasoning, driven by that scaled RL and advanced tool use, likely amplified by the heavy version's parallel processing.
Truly impressive scores, especially Vending Bench showing that agentic capability. But what about multimodal, beyond reading X media, and what's next on the roadmap? Are there any gaps between the official hype and user experience?
The official line for the Grok 4 API is frontier-level multimodal understanding. It boasts that 256K context window, advanced reasoning, real-time search across X-Web news, and strong enterprise security certs.
Sounds great on paper.
But this is where those Reddit user reports offer a different perspective. They describe the current multimodal features as weak. They mention a more robust, general multimodal Grok is actually expected in September.
Ah, so maybe the API has the hooks, but the actual image generation or deep visual analysis isn't quite frontier yet in practice.
That seems to be the implication. The capability might be there foundationally, but perhaps the performance or breadth isn't meeting community expectations yet, especially compared to models strong in image generation. It suggests visual processing is still an area under active development. For voice mode, XAI promises more realism, better responsiveness, a new serene voice, and crucially, the ability for Grok to see what you see through your camera for live insights.
Like having an expert looking over your shoulder.
Exactly. Real-time guidance based on vision. Huge potential there. Now, the disappointing realities from users, that 256K context window, while big, is seen as behind the curve compared to rumors of Google's Gemini hitting 1 million plus ones. Shows how fast expectations are moving.
The goalposts keep shifting.
They really do. Users also report painful throttling strict rate limits on XAI's platform if you're not on the higher tiers. That can hinder development and usage. And latency is a recurring complaint. Around 13.58 seconds time to first token is considered sluggish compared to the snappier feel of GPT-4o or Claude Opus. That delay impacts the feeling of real-time interaction.
So powerful, but maybe not as fluid yet. What's the roadmap?
Looks aggressive. August. Grok Code, a developer-focused version. September. Better multimodal and browsing support. October. Grok Video Generation. Their ongoing focus is scaling RL, tackling complex real-world problems, improving multimodal, and generally making Grok smarter, faster, and more efficient. Lots planned.
Okay, let's put them head-to-head now. GPT-5 versus Grok 4. Based on the artificial analysis data and everything else we've gathered, what are the direct technical comparisons that jump out?
All right, side by side using artificial analysis in community insights. First, context window. GPT-5, at least the high-tier version, is reported at 400,000 tokens. That's roughly maybe 600 pages of text it can handle at once.
Huge context.
Massive. Grok 4 comes in at 256,000 tokens. Still substantial, maybe around 380 pages, but significantly less than GPT-5's top tier. So GPT-5 offers more room for really long documents or complex multi-turn interactions before potentially losing track. That's a clear advantage for certain tasks.
Release dates.
Grok 4 was slightly earlier, July 2025. GPT-5, high tier, followed in August 2025. Both officially support image input, so they have some multimodal capability baked in. And crucially, both are proprietary, closed source, no looking under the hood for the public or most researchers.
Right. And you mentioned the context window disappointment on Reddit.
Yeah, specifically GPT-5's free tier, apparently having only 32,000 tokens context. People see that as limited, especially with Google supposedly aiming for 10 million with Gemini 3. It highlights that even as the top-end capabilities surge, access and scaling across different user tiers are still major competitive points. The contest window arms race is definitely on.
Beyond the specs, what about their core philosophies, their character, if you will? What are their distinct strengths based on the claims and user feedback?
Good way to frame it. GPT-5's character is built around being smartest, fastest, most useful, with that thinking built in. Its strength seems to be robust, reliable, accurate reasoning, especially in high-stakes domains like law and science, backed by that impressive hallucination reduction.
The surgeon.
Exactly. Precise. Follows instructions well. For developers, its agentic features, UI generation, complex tool chaining are key differentiators. It feels aimed at dependable, enterprise-grade performance where accuracy is critical, and its speed, 190 TKs, supports high-throughput use cases. Grok 4, on the other hand, emphasizes frontier intelligence via scaled RL and that native tool use. Its strengths shine in those record-breaking benchmark scores for reasoning, math, coding. Its agentic power shown in Vending Bench and the unique X integration is also a major feature.
And Grok 4 heavies architecture.
That parallel test time compute, the multi-agent setup, is a unique architectural choice, contributing to its benchmark prowess and robustness on complex problems.
But the user experience difference.
Latency. Grok 4's 13.58 seconds to first token is noticeable. Feels sluggish to users compared to the faster models. GPT-5 seems quicker off the mark once it starts generating, so it's maybe a trade-off. Grok's potentially deeper multi-path deliberation versus GPT-5's faster, precise execution. Different strengths for different needs.
A fantastic comparison. Now, as we dig into these incredibly advanced models, it's clear there's still a lot we don't know. What key technical details do our sources just not cover? What are the big unanswered questions for those of us who want to get really deep into the weeds?
This is crucial, getting past the marketing to the core unknowns. First, the specific architectural differences. We hear scaling or parallel compute, but what are the actual innovations in the transformer blocks or network design?
Right, what makes GPT-5's reasoning deeper? What exactly gives Grok 4 that 6x compute efficiency? Is it novel attention mechanisms, different layer structures? We just don't know the specifics of the neural networks.
Exactly. Second, training data. We hear expanded verifiable data, but what data? How much? How is it filtered? What specialized data sets fueled GPT-5's domain expertise or Grok 4's coding scores? The data is arguably as important as the architecture, and it's almost entirely opaque. That makes understanding capabilities and biases incredibly difficult.
A black box inside a black box.
Pretty much. Third, the mechanisms behind thinking built in or parallel compute. How do they actually work? Are they explicit algorithmic steps, maybe manipulating symbols internally, or just emergent properties from massive scale and clever training? How does Grok 4 Heavy's multi-agent setup architecturally differ from GPT-5's agentic chaining? Is it truly distributed? These details matter hugely for building reliable autonomous systems. A real cost-benefit analysis. We see some pricing, but what's the true computational cost to train and, more importantly, run these models at scale? What infrastructure is needed for an enterprise to really leverage them, especially with things like rate limits? Understanding the operational costs, energy use, environmental impact that's largely missing, but vital for broad adoption and sustainability assessments.
And finally, the openness issue.
Or lack thereof. Both are proprietary. What does that mean for independent research, for verifying claims, for building upon these powerful tools? Especially given OpenAI's original open mission, how does its current closed nature impact the whole AI research ecosystem? That tension between commercial speed and open science is a huge underlying technical and philosophical question that these announcements don't really address, but it shapes everything.
We've certainly taken a deep dive today into GPT-5 and Grok 4, two truly formidable models pushing the AI frontier. We've seen GPT-5's impressive gains in core intelligence, that critical reduction in hallucinations, and its strong focus on enterprise-ready agentic capabilities. It's setting a high bar for reliable AI. And on the other side, Grok 4 shows stunning benchmark performance, particularly in complex reasoning and math, coupled with innovative native tool use, even if some user experience aspects like latency are still catching up.
Absolutely. And it's crystal clear that this competitive dynamic, maybe even fueled by those historical disagreements we talked about, is just accelerating everything. The push and pull between these major players is driving constant innovation in efficiency, in reasoning, in making these things actually useful in the real world almost faster than we can track it.
So as these models become increasingly agentic, able to chain tools, run complex workflows, see and talk in real time, here's a thought to leave you with. What's the next big leap in their autonomy? How soon before they move beyond just assisting us to actually initiating and managing complex projects or processes themselves, maybe even across different fields? And what entirely new technical hurdles in reliability, in control, in predictability will that leap present for developers and for deploying them safely in the real world? That shift from reactive helper to proactive agent feels like the next major frontier. Keep exploring, keep asking those tough questions, and keep that curiosity burning. We'll keep bringing you the critical insights from the absolute cutting edge of technology, always focusing on the technical details and their implications. And remember, for the latest AI and ML research papers and updates, head over to our webpage, neuralintel.org. Thanks for diving deep with us.